Assalamualaikum and good evening to my lecturers and my fellow friends. So, today we are going to talk about our project, which is the sustainable of glass. If you guys are wondering, how are glass made? First, the sand is heated in a furnace with waste glass, soda ash and limestone in a commercial glass plant. And then, the soda lowers the melting point of the sand, which saves energy during manufacturing, but it produces a glass that dissolves in water. The limestone is added to prevent this from happening. Lastly, the finished product is known as soda lime silica glass. We can see ordinary glass all around us.
So Article 1 is combination of using waste material and glass sustainable. As the population grows, so as the concrete waste and glass sustainable grows, there are many industrial infrastructure and residential construction being built every day. We can use the waste to recycle and make them as useful and better things. We also can reduce the greenhouse gas emission if there are fewer waste materials. As we can see from the statistic, concrete waste has 12 to 40% of participation from construction and demolition of the building. The concrete will be divided into two categories, which is fine or coarse particles. Other than that, glass can be recycled without the loss of quantity. Glasses are more to end up in the landfill. Glass waste is more an attractive option rather than the cement waste, and has a higher value since the glass is not very high quality condition. Next is material waste glass. The waste glass used in this study is a typical soda lime glass obtained from transparent glass bottles. Crushing and dry drinking are used to obtain glass powder, which is then sifted to obtain the desired particle size. Glass is collected from recycling bins. The objective of this type of analysis is to identify the major phases in a series of unknown mineral powders. The significance is based on the ability to observe the shape of the glass particles, which are angular and crushed in this case, as well as the perception of their granulometric distribution. Next, there are two methods, which is dry density and consistency. Dry density test was carried out after 28 and 90 days of curing. The samples were dried for a minimum of 24 hours in a 105 Celsius furnace before being weighed. They were then immersed in water for another 24 hours and the saturated weight was determined. And after that is consistency. After filling the mold with fresh mortar, the flow table was raised vertically to extend the mortar on the disc, while shaking the flow table 50 times at a constant frequency.
Article 2. Properties of concrete when glass powder for partial fine aggregate. Introduction. Glass is produced in many forms. All types of glass have a limited life in the form in which they are produced and need to be reused in order to avoid environmental problems. Waste glass is crushed to grain size or sand size, and it can be used as an alternate material for natural sand as partial replacement. The primary objective is to utilize as much waste glass as possible. This research has been conducted to identify the suitable composition of glass dust waste as fine aggregate replacement material in concrete, and also to study the mechanical properties of concrete. The first material used is cement. Cement is used in this research should pass IS specifications. Portland cement is very common and is available everywhere. The second material is fine aggregate. Locally sourced river sand that could pass through 4.75 millimeters of sieving can be used. The third material is glass powder. Glass powder are crushed by crushers and sieved in a 2.36 millimeter sieve. It is used to replace the fine aggregate in different percentages. The fourth material is coarse concrete. Coarse aggregate that would be used is strong, impermeable, durable and capable of producing a sufficient workable mix with a minimum water-cement ratio. And the fifth material used is water. The pH value of the water must be between 6.5 and 8. It must be free from impurities, but most importantly, it should be free from iron. Experimental methodology. The concrete has a certain mixed proportion, which is cement, fine aggregate, coarse aggregate, and a ratio of 1:1 to 5:3. The water-cement ratio must be at 0.45. This will create a normal concrete. Experimental investigation. We can get the strength of the concrete if we use the compressive strength, split tensile strength, and flexural strength. This is when the natural coarse aggregate is being replaced by waste glass and waste powder. The workability of the fresh concrete can be measured by the slump values. The concrete must be mixed until its uniform consistently has been achieved. Results. For the slump test, the workability of concrete made by using glass powder has been determined with different replacement level. The workability of concrete made using glass waste powder as fine aggregate decreased with increase of percentage of replacement and water-cement ratio. For the compression strength test, the compressive strength values were nominally increased when increases of glass powder waste replacement level of percentages in concrete. Split tensile strength test. Split tensile strength test decreases steadily with increasing percentage of glass waste powder replacement, and the optimum strength is at 20% replacement level.
Okay, for the third article, that is mechanical and fracture properties of UHPC containing waste glass sand. Glass waste is non-biodegradable, and the disposal of glass waste to landfills due to poor recycling practices increase the dependency on natural resources. The recycling process begins with glass collecting, in which different types and colors of glass are separated to ensure that the chemical composition is appropriate for the intended application. The crushed glass can be blended with raw materials and burned to high temperatures in a manufacturing furnace to melt the glass mix. The liquid glass mixture is subsequently blown or pressed into new glass item, leaving the kiln. Okay, for the result, the waste glass has the potential to be used as partial clinker replacement or a cement additive in Portland cement blends due to its chemical composition and potential pozzolanic activity. This section looks into the mechanical qualities that have been discovered as a result of using scrap glass in these two applications. So in the conclusion, the waste glass is being used as the replacement of the aggregates. Meanwhile, the working, mechanical, fracture and microstructures concrete properties will be investigated for further knowledge. The waste of glass sand being as a replacement material for the traditional aggregates could increase the fluidity of the concrete. If the replacement degree is 75%, the compressive strength would reach its maximum potential. The greater the compressive strength of the concrete specimen was, the greater the maximum energy value presented. Okay, that's all from us. Thank you.